Hi, I'm Darren and welcome to Level Up Double E Lab. On my channel I have restored a lot of Heathkit gear over the last couple of years, but I haven't done something made by R.L. Drake yet until today. I'm starting a new series to repair and restore this TR-3 transceiver. Let's get started. For those of you who aren't familiar with the R.L. Drake company, there's plenty of very detailed info about them online, so I'm only going to give a very brief summary here. Beginning in 1957 and continuing for over 4 decades, they manufactured a wide variety of well-designed and well-built amateur radio gear, including receivers, transmitters, and of course, transceivers. They reached a peak of popularity in the 60s and the 70s when the majority of their gear was still vacuum tube based. And even today, vintage Drake gear is highly prized by hams and is still fairly easy to find and keep in operational condition. And the TR-3, introduced in 1963, is a prime example of that longevity. It's a transceiver that's capable of CW, single sideband, and AM operation on 5 of the HF amateur bands. Its feature set is impressive for a rig of that era, not the least of which is 300 watts peak envelope input power on single sideband operation. I do own several other pieces of Drake gear, including an R4A and a T4X. These are examples of what are affectionately called the Drake Twins. They're one of my favorite tube rigs and one of my all-time favorite restorations. Maybe I'll do a short episode on them in the future. Getting back to this particular TR-3, let's take a closer look at it. Cosmetically, it's in really good shape. All of the controls still rotate freely, including the main tuning dial. Both sides of the case are still in good shape, and the back of the unit looks fine. There is this added terminal strip, more on that in a moment. The top left corner is a bit smashed. Either it got dropped or something got dropped on it. And the red calibration slider has badly faded. That happens to all Drake gear, and it is easily fixed. But all things considered, it's really not that bad off for something this old. Let's take another look at this terminal strip. Now this is definitely not factory original. I'm guessing by this TR relay label stuck on here that it's somehow tied into the transmit-receive relay. It's also missing about half of the screws on the top and bottom covers. That's pretty common, and I've got new replacement screws that are a good match for the factory originals. And speaking of fasteners, there are 4 threaded holes on each side of the top cover. Now believe it or not, those are there to make it easier to put the TR-3 in your car. I am not making that up. Here's the R.L. Drake illustration for the MMK3 mobile mounting unit. It includes these handy figures to show 4 possible orientations. But wait a minute, the TR-3 can't run directly from 12-volt DC power. No worries though, R.L. Drake has you covered. All you need is the DC-3 power supply, which will create the necessary DC high voltages. It's an early version of a DC to DC boost converter, using a pair of transistors and a pair of transformers to first generate high voltage AC, then rectify it back to high voltage DC. Now, the DC-3 is a very rare bird. They're hard to find and not cheap when you do stumble across one. And as much fun as it sounds to tune a TR-3 while driving down the expressway, I've got no intentions whatsoever to put this bad boy in my car, so I'm going to use a much more commonly available Drake benchtop power supply. And fortunately, this TR-3 came with a friend. It's the RV3 remote VFO. The RV3's primary purpose, of course, is enabling split frequency operation. This selector switch lets you choose which VFO does what. But the RV3 is more than just a VFO. It also includes an integrated speaker. And looking around back, all these cables should give it away. Tucked inside it is an AC3 power supply. Now that's just what I need for benchtop power. I wish I had a cool and interesting backstory on these 2 pieces of gear to share with you guys, but I really don't. In fact, it's a really short story. I know my dad bought these at a ham fest about 15 years ago, and he used the TR-3 on the air for a couple of years, and I seem to remember him saying that the transmit side of it quit working. It would receive, but not transmit. So that's where I'd have to start the troubleshooting. But before I can even get that far, I'm going to need a power supply. So that means the first project is to fix the AC3. But first I need to get it out of the RV3. It's quite heavy and extracting it is a bit tricky. Fortunately, the manual comes in real handy here. You can stuff it into this gap right here. Then flip the RV3 upside down and loosen the 4 screws holding the 2 of them together. Once the screws are removed, the AC3 drops down to rest on the manual, then you can pull on the manual to gently slide the AC3 out of the case. Brilliant! Now we can get a good look at it. There's not that much dust accumulation on it, and there's no discoloration of the transformer. The paper tube electrolytic caps do have the appearance of leaking electrolyte though. I'm not 100% sure that's what that is, but it doesn't matter. I'm going to replace them all anyway. Let's take a look at the schematic. Functionally, it's very similar to the Heathkit HP23 power supply that I restored in my series on the HW101, meaning there's a high voltage DC section for powering the output RF power tubes, a medium voltage DC section for powering the rest of the tubes, a lower voltage negative DC section for biasing the grids on the output RF power tubes, and finally a 12 volt AC section for all of the tube filaments. On the primary side, there's dual windings which can be configured for either 110 or 220 volt AC operation. Now for disassembly, starting with the bottom cover. A previous owner thought it was important to put a capacitor discharge reminder label on it. Always good advice, but it takes more than a minute to remove all 8 of these screws anyway. At any rate, I'm in. Let's see what we've got here. On these old power supplies, sometimes it's more about what you don't see than what you do see. And on this one, I don't see any fried components, nor do I see any burnt wiring. The diodes might have been replaced at one point, but for sure there's no questionable repairs, nor any scorch marks left by prior failed components. So this particular AC3 is shaping up to be an easy restoration. And that restoration begins with stripping out all of the existing DC components. I'm not going to save any of the diodes, resistors, or caps. I'll save the bias potentiometer though, it checks out fine. And so does the transformer. Its primary and secondary windings all have reasonable resistance values. A common repair method for these power supplies is to use a circuit board to hold and route all of the new caps, diodes, and resistors, which is then in turn attached to the chassis. Years ago, I repaired another AC3, and for it I used a kit sold by Mike Bryce, WB8VGE. Unfortunately though, at the time of me recording this episode, it looks like he's suspended his business. So I designed my own. Here's the DC portion of the schematic redrawn in KiCad. I've kept the same component IDs wherever possible. And here's the physical layout. I chose a board length and width that will fit on top of the chassis. And there's plenty of room for everything, including these 6A10 diodes. Now, regular old 1N4007s would probably work, but I've got dozens of these 6A10s, and it's time to put some of them to use. Here's a 3D view of the assembled board. Note that I used 2mm traces and 1.5mm spacings. Probably overkill for the currents and voltages, but there's no sense in trying to squeeze things to a minimum. And I had the board fabbed. It's a simple design, and I could have made it myself like I did on the Heathkit HP23, but I do love plated through holes and pretty silk screening. Assembly only took about 30 minutes. Notice that I did space some of the resistors off the board by several millimeters. That's to give them more air circulation. They're going to run a bit warm. Okay, I finished the teardown of the power supply and the cleaning as far as I'm going to go. I did not remove the transformer from the chassis. The main reason is not because it's difficult, but here, let me flip it over carefully because this is quite heavy and show you my reasoning why. The insulation on the primary and secondaries looks to be in good shape. No issue there, but there's some really tight bends that they're routed through to get them out of the transformer and through these grommets, and I'd have to straighten the wires quite a bit and manipulate this insulation quite a bit, and I think it's just not worth the risk of damaging the insulation or worse, fracturing a wire. I got it clean enough for what it really needs. This is just a power supply after all, and not the front bezel of a rig where it really needs to be a lot cleaner. So it's good to go at this point. So what I'm going to be doing, of course, is taking the populated board and I have to attach it to the chassis. So it's going to just be on standoffs a little bit above the surface of the chassis, roughly in this area here. I do have to clear the bias adjustment pot, so I have to give myself enough clearance there. But I sized this board so that it would fit in this space without any issues. And of course I've got extra blank boards I can use as a template to mark exactly where I'm going to drill my holes. I've got some standoffs here about, what are these, about
3/8 of an inch high or so that'll stand off the four corners of the board. And just a quick comment of where I got my hardware for those standoffs. These two drawers here that are just full of all kinds of screws, standoffs, washers, terminals, you name it. This is all the stuff that I salvaged from, I think it was a $5 junk audio generator filter combo. It was a professional piece of equipment, probably weighed about 25, 30 pounds. Picked it up at a Hamfest just for salvage about a year ago, just for this purpose, just to strip it down. I got all kinds of good stuff, not just the hardware, but a lot of BNC connectors and other things. And this item was clearly a design, clearly not, I should say, an example of design for assembly. There must be 50 different styles, lengths, types of fasteners alone in that thing. That thing was just way too expensive. So someone's overkill became my gold mine a few years later for this kind of hardware. And then I've got grommets, of course, here. I'm going to have to route these wires up through the chassis, and what I will most likely do is drill a couple of holes in these larger areas so I can snake them through and put some rubber grommets there, rather than just have them come through these large apertures where the capacitors used to feed through, because there's a chance that they're going to rub up against an edge there. So I'll make sure I have grommets. And then last thing I would say is I did save these terminal strips, and I do have a few more of this style. So if I need to extend some wires underneath to reach, I'll do that. So at this point, I'm going to proceed with the reconstruction. All right, I'll just cut to the chase. The work is done. There's enough of these AC3 repair videos online that I really don't need to show all the soldering work and other things that I did. But I will point out a couple of the unique things that I've done here. One of which, of course, is the board that I've made. You can see, like I said earlier, it fits right on top of the chassis. Now the AC4, a later model of this power supply, is a little more clean, I guess you could say. When you go to modify it, I think the transformers turn 90 degrees, and there's definitely more structure on top of the chassis where you can take this circuit board and put it vertical. There's even a cover for the whole thing. It's a lot more elegant looking power supply, but this is what you have to work with here on the AC3, and this board does fit on here nicely, and all the wires route and run underneath. I did convert it to 3-wire for safety, and unlike most of my usual projects where I put that standard size socket and then a removable cord, there really isn't that much room down here to cut and put in that socket, so I just put in a cord. But you can see I've got this really nice strain relief. I've got a collection of these that I picked up years ago, and as it turns out, this particular size fits right into the hole that was there already in the chassis. Didn't have to drill anything, so now it's very secure, nice strain relief, and it's got the safety 3-wire connection on there. So let me do this now. Let me turn it upside down, turn it over so we can take a look at the wiring on the other side. All right, here's the bottom of the chassis, and I didn't get too crazy with trying to make the wiring super neat. Just tried to make it so that it had good strain relief and also not up against an edge somewhere where it could potentially get cut. And as you can see, I did salvage one of those, I think they're Bakelite insulators that are on the bottom of these original caps, this guy right here. So there's an extra one. Just took that off and put it in that aperture so it could act as an additional abrasion resistant piece for the wires that go through there. Now I was able to put in some rubber grommets here, and there was one here. This one worked okay, but this one did not. When I actually routed the wires, what happened was by the time they got to their destination on the circuit board, they ran right over. You can kind of see one right here and one right here. They're the terminals on those through-hole caps, and those are really sharp, and I didn't want to have the wires up against that long term. So I rerouted the wiring and ended up just using that piece to provide some additional abrasion resistance. On the primary side, you can see over here the wires coming in, and I did add 2 AC rated caps here for some additional filtering. The AC3 doesn't have these, but the later model AC4 pretty sure does, and they're just from the primary and the neutral to ground. And I don't know if there's really that much RF here, but it can't hurt to put those in, and I had them anyway, so I put them in. Other thing to comment on here, I would say, was when I was routing the connections that are on the cable that goes to the TR-3, this harness right here, it was too short. So what I ended up doing, I just stripped off this much of the jacket. You can see how much wire I actually needed to make these connections, and it's not a problem. This thing is like 4 to 5 feet long, so there's plenty of length here to connect it up to the TR-3 when it's done. And I prefer doing that over having to put in additional terminal strips and then more solder connections and more jumpers to get to the board. This worked out really well. So at this point, it looks like the next step's going to be to hook this up to the dim bulb and test it out. Okay, I've got the AC3 connected to my dim bulb tester, and I need 4 meters here to look at all the outputs simultaneously. So upper left-hand corner, of course, I'm using my Heathkit IM13 vacuum tube voltmeter. That's connected to the high voltage output, the 650 volts of DC output. To its right, the tiny little digital multimeter, that's just looking at the filament output. It's the 12.5 to 13 volt AC filament power. And to its right, the Keithley, that's looking at the medium voltage DC. That should be about 250 volts. And then lastly, the DMM in the center of the screen there, just behind the bulb on the dim bulb tester, that's looking at the negative voltage bias circuit. That's supposed to be between minus 45 to minus 65 volts, and that's adjustable. So we'll see where that falls. And of course, the dim bulb is being used here because when I power this up, I want to be able to run the AC through the light bulb in case there's a problem. So let's flip it on and start cranking it up.
This item contains hazardous voltage and safety precautions must be followed. If you're following along and working on your own version, you're doing so at your own risk.
And right away, I'm seeing all 4 meters move, and they're moving in the right direction. Again, the one in the middle, the center there, that's supposed to be negative voltage, and it is. And the bulb is not glowing. That's always a good sign. Take this up to maybe about 80 to 90 volts. And pause, and the bulb is starting to glow a little bit, and that's to be expected because there is some power being consumed by the power supply. So I'm going to pause it right there and just do a quick visual check on all 4 meters, and everything seems to be moving in the right direction. Again, the negative voltage is supposed to be negative, and it is. So what I'm going to do at this point, everything seems to be stable. I'm going to back down the magnitude, and I'm going to take the bulb out of the circuit. So run this down a little bit, flip my switch here, take the bulb out of the circuit, and now run this up and try to get to about 110 to 115. So there we go. Pause right about there. And doing a quick check here. So the vacuum tube voltmeter is showing pretty close to 600 volts. The Keithley is showing 260. The filament voltage, 13.3 volts, that's good. Actually, 3 of those are good. And then lastly, the negative voltage at negative 66 looks good as well. Now that's adjustable, and I'll show here real quick adjusting that by turning the little potentiometer that's on the power supply. I can get the screwdriver in there. There we go. So when I do the setup on the TR-3, I'll be adjusting this to set the bias voltage to get the appropriate idle current on the tubes, and this needs to be adjustable, and it is adjustable through a range that one would expect. So that's good. So I'm going to set this later to probably about minus 80 volts or so should be fine for now, but I'll set that later when I'm actually working with the TR-3. But this is all encouraging. No magic smoke coming out from over here, and there's no disturbing sizzling sound. So I think this power supply is looking good.
All right, with power restored, I can move on to troubleshooting and figuring out what's ailing this TR-3. And I'm optimistic I'll be able to figure it out because of my past history of working on my other Drake gear. That's all been very positive. I was able to find a lot of good information online and guidance for figuring out what some of these issues are. And they're generally not that difficult to repair as long as parts are still available if it is something like a rare tube or whatever that's gone out. So fingers crossed. And same thing with the RV3. This is very simple. It's essentially a duplicate of the VFO that's in here anyway. So that'll be the subject for the upcoming videos in this series. And I'm going to be bouncing back and forth, of course, between this TR-3 project and my Microtac cell phone project. I tend to do that on my channel. I got a couple projects going at any given time and tend to switch off between the two of them and hopefully keep the interest up for all of you guys. And as always, I do thank you for watching my channel and hope that you are enjoying this material. So until next time, bye for now.